Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapagod. Dear students, come today we will discuss one numerical on heat transfer. First I will read the problem, then I will solve this problem step by step. Determine the heat flow across a plane wall of 10 cm thickness with a constant thermal conductivity of 8.5 watt per meter Kelvin when the surface temperatures are steady at 100 degrees Celsius and 30 degrees Celsius. The wall area is 3 meters square. And also find the temperature gradient in the flow direction. This is the given problem, dear students. If you want to solve this problem, first what you have to do, you have to draw a relevant schematic diagram. How to draw that schematic diagram? You can see here now. So, dear students, what actually is telling now? He is telling there is a plane wall of 10 centimeter. Yes, here is a plane wall. You can mark. Okay, here is a plane wall of 10 centimeter. 10 centimeter means what? You can take here it is a 0. Here it is 0. That 0 you can mark it as a x1 distance. Here you can mark it as a x2. That the x2 minus x1 is nothing but what? L. That is nothing but thickness of the given plate or a plane. You can consider, dear students. Okay, one thing. Next, a constant thermal conductivity. Yes, dear students, when there is a material, right, that plane of wall is made up of some materials. That materials having some thermal conductivity. That plane wall having thermal conductivity. That thermal conductivity we can mark it as a small k here now, thermal conductivity. Okay, now when the surface temperature are steady, that means what, dear students, we can see here now, when it comes to heat transfer, heat is flowing in this particular problem. You can see here now, heat is flowing in this direction from left to right. That heat transfer is represented by notation that is Q. So high temperature region we will mark it here as a T1. The temperature at high temperature region is represented as T1. The temperature at low temperature region we will mark it as a T2. So both he has given 100 degrees Celsius high temperature region, that is T1. You can call it as a left side, and he has given one more temperature, that is T2, 30 degrees Celsius. This is the given data. Okay, one thing. And also you can see here now the wall area. The wall area you can consider that wall area you can mark it as a actually. So that also he has given the how much he has given 3 meters square he has given, dear students. Now these all the things he has given. For this given data we need to solve the temperature gradient. Okay, so now what I will do, dear students, now I will list out the given data. What all things he has given? First one, thickness of the plane wall. Thickness of the plane wall, what I will do, I will take it here L. L is nothing but what? I can write it here x2 minus x1, that is equal to 10 centimeter he has given. So but that 10 centimeter you can convert it into meter by dividing 100. So 10 centimeter divided by 100. So how much you are going to get? 0.1 meter. That L he has given. So sometimes we will take dx also. Dx or L. Okay, thickness of the plane wall. Fine. Next, he has given thermal conductivity. How much he has given thermal conductivity, dear students? That thermal conductivity is represented as small k. That is equal to, he has given 8.5 watt per meter Kelvin he has given. Okay, fine. Next, the surface temperature. Surface temperature, how much he has given, dear students? You can see here now. So T1 he has given how much? 100 degree Celsius. I will write it here 100 degree Celsius. Then T2 he has given. So that is T2 equal to 30 degree Celsius, dear students. Now, so now change in temperature we will mark it here dt. So the dt is nothing but what? T2 minus final temperature minus initial temperature. That we can take it here T2 minus T1. So how much it is now? T2 is equal to 30. T1 is equal to 100 degrees Celsius. So therefore dt is equal to how much I can write? Minus 70 degree Celsius. Why it is minus here, dear students? That minus indicates the decrease in the temperature. That minus sign indicates decrease in the temperature. Okay, so now fine. Now this is the thing he has given. Okay, dx also he has given. Now what we have to do? We need to calculate the temperature gradient. To calculate the temperature gradient in the direction of heat flow, what we have to do? We have to use the Fourier's equation. Fourier's equation of conduction. What is that? We know already, dear students. What is that? Q is equal to minus Ka into K into dt by dx. So first I will try to calculate the value of q here now. How to calculate that value of q? Q is equal to what? Now substitute the value. Minus what is the value of k? K is equal to how much? 8.5 into what is the area? A is given already. Okay, that A is given, that is given here. You can mark it, dear students. 1 minute. That A is given in the problem itself, that A is equal to 3 meter square. That he has given here 3 meter square. Okay, so that I will substitute here now. So 8.5 into 3, what is dt by dx? Dt is nothing but what? I will write it here, minus 70 degrees Celsius divided by what is dx? Dx is nothing but what? Our thickness of the plane, that is 0.1 meter, dear students. Now do simplification. What we are going to get here now? Okay, so now I will do here now, dear students. Here it is minus, and minus it becomes plus. You can see, you can take it, 8.5 into 3 into what you can do here now. So 70 divided by 0.1 is there. What is the answer, dear students? I will write it. Q is equal to 17850. So therefore Q is equal to what I can write now. So therefore Q is equal to 17850 watt. We can write it, dear students. Now it is a watt actually. So if you want to write it in kilowatt, you can write it, no issues. So therefore Q is equal to, how I can write now? So therefore Q is equal to 17850 divided by 1000. It becomes what? 7.85 kilowatt. This is nothing but what? Amount of heat transfer in the plane wall. Okay, now what actually is asking, dear students, is asking to calculate the temperature gradient. Temperature gradient I can calculate with the help of this equation. Where is the temperature gradient? That we can see, dt by dx. So therefore what I can do now? Temperature gradient, I can write it here, dt by dx is equal to, I will write it here now. So what is that? Q divided by, so Q minus, I will write it, Q divided by, that is K into A. So therefore what you can do, dear students, now you can substitute the value here now. What is Q? Q in terms of watt, 17850 divided by what is K? That is 8.5. One thing, just a minute. Okay, so now here is equal to, minus sign is there, minus I am taking here now, 8.5 into 8.5, what we can do? Area is nothing but what? Meter, 3 meters square. So do simplification again. So what we can do here now? What we will get, what we are going to get, I will keep minus as it is. So 17850 divided by 8.5 into 3. What is the answer, dear students? That is equal to, how much you can write it here now? Minus 700. It is watt. Okay, so minus 700. So therefore what you can write it here, dear students? We can see here now. So therefore I will write it here. So therefore, so dt by dx is equal to minus 700. What is the unit now? Here it is a watt, right? So you can write it in, here it is a watt, and here it is a watt per meter Kelvin. Then here it is what? Meter square. Then what happens now here now? This is what? Change in temperature. You can write it, change in temperature, that is in degrees Celsius, divided by, it is in meter. Okay, so therefore dt by dx is equal to minus 700 degrees Celsius for unit length, you can, or unit thickness, you can call, dear students. Now this is what? Our final answer. This is our final answer, dear students. And one more thing, you have to keep it in mind. This schematic diagram I can express in terms of heat conduction circuit. What I can see, so now here, so I will mark it here now. So here it is a T1, then there is a resistance. Now when it is a heat flowing rate, heat will flow, but there is some resistance. That resistance is represented as R actually. This is what, now I will mark it here now, dear students. This is, 1 second, I will write it the numerator. It is T2 and it is R actually. So then heat is flowing in this direction. You can show the direction of heat. Then heat is represented by what? What is the notation you can give, dear students? You can give notation for heat transfer as Q. Okay, Q is moving in this direction. This is how to solve the numerical, dear students. Now the final answer is minus 700 degrees Celsius per meter. This is how to solve the problem. Thank you. We'll continue next class.